All right, so let's start with our bell work here. Just some old stuff that we've been working on. I just want to bring it in so we can practice some of the skills that we've learned so far. One of the things is that you need to be able to simplify a root. So this one is a square root. So if it's a square root, there's technically a 2 outside the root, and that just helps me when I'm simplifying a exponent. So I have to simplify a square root of 49. So the square root of 49, most people know that when they take a square root of 49, it gives them 7, because 7 times 7 gives us 49, and that's a pair, and we know that pairs come out of a square root. So the 7 comes out, and then the square root of a to the 13. Now, when we are taking care of exponents, we always divide the root into the exponent. So 2 goes in 13 about 6 times. So a to the 6th power comes out. But 2 times 6 only makes 12. And if you subtract that from 13, that means 1 was left over. So that 1 means that that's the leftover exponent, and that will go back into the square root as a to the 1st power. Or you don't have to write that one, I just did to be explicit. And then this b is to the 10th power, so 2 goes into 10 at least 5 times, and that worked evenly, so b can come out as 5b to the 5th power. There we go. All right, so then this looks like our final answer here. All right, and this one here, I have 2 parentheses, so I do need to FOIL. I'm going to multiply the first with the first, so 2 times 2 gives me 4. 2 times 2 square root of 3 is going to be this 2 times this negative 2, which makes a negative 4. And then I'm going to drop down the square root of 3, so that just comes down. And then I'm going to multiply the 2 square root of 3 times 2. So 2 times 2 gives me a 4, and that's a positive sign. So this is plus 4 square root of 3. And then I'm going to multiply the last terms together. So 2 times negative 2 is negative 4. And then square root of 3 times the square root of 3 is square root of 9. And looking at this, I immediately notice that the middle term, that one's a negative 4 and that one's a positive 4, and they both have a square root of 3, which means that you can actually cancel out these terms because that one's a negative and that one's a positive. Since they're almost the same but different signs, they're going to cancel. And then I have the square root of 9. Square root of 9 is actually 3. So I'm going to multiply the 4 with the 3 to get a new number. But first, let's drop down the 4. I'm going to drop down the minus sign here. And then this is a 4 times a 3, which is 12. 4 minus 12 gives us negative 8. So negative 8 is our final answer. I also want to mention something. So this is the end of our bell work, but I want to show you something here. You see how this root has a square root of 3, and when we multiplied it by another square root of 3, we got a square root of 9, which eventually led to a 3. Well, you can actually skip this square root of 9 step and go straight to 3. So anytime you have a root and you multiply it by the same root, so let's say I have a square root of 7 times the square root of 7, we know that 7 times 7 is 49, and then if you take the square root of 49, it's just 7. But I actually don't have to do this step, because whenever you multiply a square root that have the same number underneath, and this is just for square roots, if they're both square roots and they have the same number, the roots cancel, giving you the number that's underneath it, which is 7. So if I had a ridiculous number here, let's say this here multiplied by 1, 2, 2, 3. Well, if I multiply these square roots, they both are 123 underneath, so the roots will cancel, and my answers are going to be 123 as my final answer after I multiply the roots. So this is only when you have the same roots being multiplied together, and it has to be a square root. So that just some tips and tricks to help you simplify a little bit easier. All right, let's get into today's lesson. Okay, so today's lesson is about simplifying with division for roots. So one of the things we need to know is that when we are simplifying a radical or a root, you have to separate the numerator from the denominator and simplify separately. So in other words, I'm going to separate the top and the bottom. And when I do this, I'm going to give the top its own root, so still a square root of z to the 9th, and the bottom its own square root. So I can, if I have a square root and a fraction inside, I can easily just split them up. And when I do this, then I can just solve the problem separately without having to deal with both of them at the same time. So remember, this is a square root, so that's why I put the 2 out here. 2 goes into 9 about, 2 goes into 9 about at least 4 times. So z to the 4th power is on top, and it's outside the root. But 2 times 4 is 8. That means if I subtract that from 9, I still have 1 left over. So z to the 1st power goes back inside the root. And then for the bottom, 2 goes into 5 at least 2 times. So, y to the 2nd power. And then I have 1 y left over, right? Because in this case, 2 times 2 is 4. If you subtract that from 5, there is still 1 left over, and that's why the 1 is there. And that's my final answer, because I can't really simplify or combine a z with a y, so there's no need to combine it any further. This one here is another square root. And so if I have a square root here, again, I do need to split them up into 2 roots, one for the top, one for the bottom. So I have a square root of 5a to the 5th. I'm going to put that 2 on the outside just to help me out. And then b to the 13th power on the bottom. So for the top here, square root of 5. Square root of 5 is not a nice number. In fact, if you put this in the calculator, I believe it's going to give you like a decimally number, because 5 only breaks down as 5 and 1. And there are no pairs from here. Whereas a square root of 4 is a nice square root, because we know that 2 times 2 gives us 4, and that's a pair of 2's. A pair can come out of the root. But in this case, 5 times 1 doesn't give you any pairs, and 5 is a prime number, so it won't be taking the square root nicely. So if you can't take the square root of 5, you keep it under the root. So I'm going to make my square root here and put the 5 underneath. Now the a here to the 5th power, 2 goes into 5 at least 2 times, and then I'll have 1a left over, so I'll put that back in the root. And then the bottom here, 2 goes into 13, for b about 6 times, b to the 6th power. Now 2 times 6 is 12. If I subtract that from 13, that means I had to have 1 b left over, so that goes back inside the square root. And then that's it. Okay, so before I do the last slide on the journal here, I kind of want to do 2 example problems from your homework packet. And so this is homework packet 10, page 5, the last page. I'm going to do 1 and 2 with you using the methods that we've learned so far. So this is a square root of 4x to the 6th and 9y to the 4th power in the bottom. So again, we're going to have to separate them into 2 roots, one for the top, one for the bottom. Once we do this, we can take the square root. I'm going to put that 2 out there to help me out. So the square root of the top, square root of 4 is just 2, right? And the square root of x to the 6th, 2 goes into 6 about 3 times. So that means that x to the 3rd comes out of the root with no leftover, since 2 divides into 6 nicely. And then I have this square here. The square root of 9 is 3. 2 divides into 4 at least 2 times, so I have y to the 2nd power. And looking at this, I can't reduce 2 and 3. X and y's don't combine, so this is my final answer. Alright, this one here is a cube root, and it's the cube root of x to the 8th and 8y to the 6th in the bottom. So again, I'm going to have to split this up into 2 roots. Make sure you put the 3 that's outside the cube root, or else you might forget that this is a cube root and not a square root. Alright, the cube root of x to the 8th. 3 goes into 8 at least 2 times, so that means x squared can come out, but I still have 2 x's left behind, because 2 times 3 gives me 6. If I subtract that from 8, there are 2 left over. So there's still a square root, or I'm sorry, a cube root of x to the 2nd power. This last one part here, cube root of 8. Cube root of 8, if you guys didn't know, 8 can be broken down as 2 times 2 times 2, 3 2's. So the cube root of 8 since that is a triple, is actually 2. So the cube root of 8 is 2. It's a perfect cube root, meaning there's no leftovers. And then 3 divided into 6 for y gives us y to the second power. And then that's really it. You can't really simplify any further. So that's my final answer. All right, so I want to show you the last slide on the journal. So I'm going to switch back to the journal to go over a couple more concepts and then try out 2 more homework problems. Okay, so in this one here, we're going to be simplifying things that are a little bit more complex. So one of the rule of thumb is that you don't want to have a root in the denominator. Okay, this is known for being improper. We don't like to divide with roots, so we try to get rid of it. And so one way we can do this is that idea from the bell work, like whenever you have a number that is the same root and the same number underneath and you multiply, they actually cancel out the roots. So this answer here, square root of 5 times the square root of 5, actually turns out to be 5. So if you want to cancel out a root, you can multiply by the same root. And then when you multiply, sorry, that meant to be multiply here. When you multiply, you want to multiply to the top and bottom. So in this case here, there's a square root of 7, so I need to get rid of it. So I'm going to multiply the top and bottom by the square root of 7. Because anything you multiply to the bottom, you have to multiply to the top. So that's why the top needs to be a square root of 7 as well. Because if you have something the same in the top and bottom, technically this fraction equals 1. So you're really multiplying 1 to this fraction. But even though it doesn't feel like, you know, this is just 1, it does work, and it just makes it look a little different. So then the square root of 7 times the square root of 7, the roots will cancel, bringing out just the 7. And then 2 times the square root of 7 is just brought over because they don't multiply the insides together. 2 and 7 don't divide nicely, so then in this case, this is the final answer, and that's all I can do. So that one's pretty easy. All you're doing is multiplying the denominator by a square root of 7, or the same square root. All right, and then this one here has a square root of 3 and a square root of 2. There are 2 terms. When there are 2 terms, that's when you want to bring in the conjugate. So a conjugate is basically the same expression, but instead of a minus sign, it will be a plus sign. Or if this was a plus sign, it's going to be a minus sign. Conjugates are the same expression, but different signs. So I'm going to multiply the bottom by the conjugate because it helps me get rid of the root. And you'll see once I multiply everything out. So the conjugate to this is square root of 3 plus the square root of 2. Let me erase this now. And so if I multiply that to the bottom, I need to multiply that to the top. And so when I multiply, I like to put some parentheses around my expressions, at least the one that has more than one term, because this just helps me kind of see it that I'm FOILing or distributing. So I'm going to take the first term, 6, and multiply into square root of 3. That would give me 6 square root of 3. And I'm going to multiply the 6 to the square root of 2. So that's going to be 6 square root of 2. Basically, I just put the 6 in front of the root since I can't multiply it in. Then the bottom here, square root of 3 times the square root of 3 is actually just a 3. Square root of 3 times positive square root of 2 is positive square root of 6. Since they're both under a root, you can multiply the insides together. So 3 times 2 is 6. And then this is a negative square root of 6. And then negative square root of 2 times a positive square root of 2 is negative 2. Square root of 2 times the square root of 2. Remember, they're both square roots and they're both 2, so you can bring out the 2. And now looking at this here, the middle terms cancel because notice how that's a positive 6 and that's a negative square root of 6. So they're identical but opposite signs, so they're going to cancel. And then looking at the bottom here, well, actually the top, it looks like that's a square root of 3 and that's a square root of 2. I can't combine these two, so unfortunately I have to just copy and paste that down because they don't combine. And then the bottom here, that's a 3 and that's a 2. So 3 minus 2 gives me a 1. And then looking at this, I'm dividing this by 1. So technically, I don't really need this one because anything divided by 1 is itself. So I'm going to shrink this down just a little bit. There we go. Oh, why didn't this go? Ooh, no, that's not what I want. Or maybe I can't shrink it. Oh well. So I'll just write this under. So this is 6 square root of 3 plus 6 square root of 2 once I divide by 1. And this would be my final answer. I guess I do have room there. All right. So if you're feeling pretty good about these problems, let's try 2 more problems from the homework where we are dealing with roots in the denominator and more conjugates being used. Okay, so let's start with number 6 here. Number 6 has a square root of 6 in the denominator, so I am going to have to get rid of that square root by multiplying it by the same root. So square root of 6 for the bottom and for the top. So when I multiply square root of 6 times the square root of 6 for the bottom, the roots will cancel, bringing out just the 6. And then the top, they're just going to multiply straight across because that's a number and that's a root. So you don't want to combine them necessarily, you just want to set them next to each other. And then from there, I can do some simplifying. I notice there's an 18 outside and there's a 6. These are both just normal numbers. So a number that goes into 18 and 6 is 6. 6 goes into 6 1 time. 6 goes into 18 3 times. So then I really have a -3 square root of 6 for the top. The bottom here is a 1, so I technically don't need a 1 in the bottom because that just means I'm dividing everything by 1, which would end up being itself for the top. So this is really my final answer. Okay, last but not least, we have number 8. Number 8, there is a expression on the denominator with 2 terms, and so in this case, you want to use a conjugate. You only want to use conjugates when there are 2 terms. So I'm going to multiply the fraction by the conjugate. So this would be the square root of 3 minus 4, and that will be the same for the top. And like I said before, I'm going to use some parentheses here just to help with the foiling. It just helps me visualize this better. So for the top here, I'm going to be multiplying the 6 in for the square root of 3, so that's 6 square root of 3. 6 times -4 gives me -24. -3 times, negative square root of 3 times negative square root of 3, negative square root of 3 times square root of 3 gives me -3. And then last but not least, negative times a negative times a negative makes a positive. And then square root of 3 times 4 gives me 4 square root of 3. So looking at this, I'm done with the top. Now I'm going to multiply out the bottom. So I have square root of 3 times the square root of 3, which is just 3. Square root of 3 times -4 is -4 square root of 3. And then 4 times square root of 3 is positive 4 square root of 3. And then 4 times -4 gives me -16. So looking at this, the middle terms here actually will cancel out because they are opposite signs but the same roots. And then the top one here, I'm looking and I see that this is a square root of 3, but so is that one. So that means I can combine their outer numbers. So if I add 6 with 4, I get, let me make a new fraction here, I would get 10 square root of 3, because I add the 6 and the 4, I get 10. They're both square root of 3, so that's why I have a square root of 3 there. I also noticed that -4 and -3 are both, so -24 minus 3, they will combine because they're both numbers, which gives you a -27. And then the bottom, you have a 3 and a -16 left, so 3 minus 16 gives me -13. My bad. So looking at this, it looks like this is all I can do. I can't really simplify any further since 10 and 13 and 27 don't really have a number in common to divide. So final answer of the day. All right, so I hope this helps you out with the homework. And like I said, if you were in class, problem number 4 on the homework is an optional homework, so you don't have to do that. That is definitely a challenge problem. So number 4 on the last page is an optional problem. All right, hope this helps you out, guys. See you next time. Bye.